This question is given in 2017 for 2 marks. The question is, a MOS capacitor is fabricated on p-type silicon. So the substrate is p-type silicon, where the metal work function is 4.1 electron volts. Metal work function Q times phi m is 4.1 electron volts, and electron affinity of silicon, which is Q times chi silicon is 4.0 electron volts, and I have given EC minus EF of silicon, which is EC minus EF is equal to 0.9 electron volts, where EC and EF are conduction band minimum and the Fermi energy levels of silicon respectively. Okay, oxide epsilon R is given 3.9 and epsilon naught is given. Oxide thickness is given. Tox is 0.1 micrometers and electron charge is given. Now, if the measured flat band voltage of the capacitor is minus 1 volt, so flat band voltage is given minus 1 volt. When you have flat band voltage, which means according to our definition of ideal Moscap that we discussed, which means this is not ideal Moscap. It has something in it, like either the work functions of silicon and work function of this substrate and the metal are not same, or even the charges in the oxide are present. So let's see. Then the magnitude of the fixed charge at the oxide semiconductor interface. Okay, now they're asking fixed charge at the oxide semiconductor interface, which means there are charges, fixed charges. They need to know in nanocoulombs per centimeter square. Okay, so flat band voltage is given, which means we know that flat band voltage is calculated and it is given as phi ms, which is the difference between the metal work function to the semiconductor work function, minus the fixed charges in the oxide over Cox times X naught over Tox. Okay, what is X naught? So if you see this, divide this metal, oxide and semiconductor. In the oxide, if the charges are present at X naught and this, let's say this is 0 and this thickness is Tox, that is what is X naught, where it is present with respect to this point. So in fact here they have given that fixed charges at the oxide semiconductor interface, which means this charge is present at oxide semiconductor interface, which means X naught is nothing but Tox. So in this particular problem, X naught is equal to Tox, hence I am taking it off. It is 1. Okay, X naught is Tox. So our flat band voltage is now nothing but phi ms minus Qox over Cox. Now flat band voltage is given. Cox can be calculated. Okay, let's find out what is Cox. Cox is equal to epsilon ox. This is 3.9 times 8.854 times 10 power minus 14 divided by Tox. So where is Tox? Tox is 0.1 micrometers. 0.1 micrometers. Now this can be calculated, but remember this is farad per centimeter. Okay, now let's calculate this per centimeter square. So this can be written as, let's find this, 3.9 times 8.854 is 34.53. 34.53 divided by 0.1, and I can write micrometers as times 10 power minus 4 centimeters. So it becomes 4 it becomes times 10 power minus 10 farad per centimeter square. Now we know Cox. Now we need to know what is phi ms. Phi ms is nothing but phi m minus phi s. Phi m is Q times phi m is 4.1 electron volts. Then phi m alone will be 4.1 volts. So 4.1 volts. Now we need to find the work function of semiconductor. So if you remember the semiconductor work function, let's say this is vacuum level, which is, let me call this E naught, vacuum level, and this is EC, and this is, let's say, EF. Okay, let me say I have EF here, EF. This energy difference is actually called the Q times chi SI. This is the electron affinity which is given here, right? Electron affinity of silicon, and this difference is also given, which is, what is that value? Let's see here, 0.9 electron volts. 0.9 electron volts. This is 4.0 electron volts. Now, what is work function of silicon is actually the difference from here to here, vacuum level to Fermi energy level. So that is equal to 4.9. So that is Q times phi of silicon. 4.9 electron volts. If you want in volts, it is 4.9 volts simply. This is equal to minus 0.8 volts. So now in this formula we got what is phi ms. Okay, and now we need to find Q ox. C ox is also known here. So let me write the formula in terms of simply Q ox. Okay, Q ox is equal to phi ms minus VFB times C ox, right? So I have sent Q ox by C ox here, this here, and multiply. Okay, so this is equal to phi ms is minus 0.8, VFB is given, VFB is minus 1, minus of minus 1 is plus 1, times C ox. This is, so let's convert this into nano here directly. Okay, .453 times 10 power minus 9. Okay, this is per centimeter square, divided by, we still have 0.1. So this becomes 0.2 over 0.1. This is 2 times this, 2 times 3.453 is 6.906. Okay, this value is nothing but 6.906. This is nano coulombs per centimeter square. This will be the oxide charge fixed at the oxide silicon interface. You see here, where is it? See, the fixed charge at the oxide semiconductor interface in nanocoulomb per centimeter square is 6.906.